My name is Bruce Williams. There's all my information. You can follow me on Twitter if you want to torture yourself. I don't really post anything useful, just I mostly complain. If you're on Elixir Slack, I'm in there in the Absinthe GraphQL channel with 1,000 other people. And I'm usually there just to watch Ben answer everybody's questions. I'm from Portland, Oregon, so this is a really convenient trip for me. I just jumped on a plane midday, didn't have to wake up early, unlike all my trips to the East Coast, and come down here, which was nice. I work for a company called CargoSense. We're based out of the East Coast. I won't go into depth here, but they're a logistics intelligence company. We do things like track really expensive packages around the world and build some hardware sensors and do some data platform type analytics. It's a cool company to work for. We have a very long sales cycle, which means we get plenty of time to figure out how to make things better, which is nice, instead of a quick sales cycle where you're constantly running. So we have time to kind of look at some of the bigger projects, which is how we ran into doing Absinthe. Like I said, we're a big company. Well, we're a small company that works with very large companies, things like airlines, pharmaceuticals, who have very specific needs, and we build very specific experiences for them. Previously, we had a REST API that was a big mess, and trying to manage what each industry needed from this shared data platform in a way that made sense and was maintainable across the team was really difficult. And back in the Rails days, we had serializers upon serializers and different controllers upon different controllers. And when we decided to move over to Elixir, we also decided to kind of revamp our API structure. So I'm the co-creator of Absinthe GraphQL, which is the Elixir implementation of GraphQL, the server side. It started back in 2015, right after ElixirConf. Chris McCord gave a talk where he mentioned GraphQL, and I said, "What's that?" I have no idea, because I wasn't paying attention really at the time. And it turns out that Facebook had just open sourced GraphQL. It came out at the same time as Relay, which was a new UI framework. And it looked really neat. And I said, well, I'm the CTO, let's do it. And that's what you get to do when you have an engineering team of about 3 people. And a CTO just means, well, you do everything. And so we went ahead and I think my commit was 2 days later. And it was a really, really bad implementation. And it went out to production maybe a little quicker than it should have. But it worked. We're now at version 1.4. We stick pretty well with the GraphQL specification, and it's probably one of the most complete implementations of the GraphQL server-side specification that's out there. I'm also the co-author of this book, which is got a very, very long title, which thankfully just barely fits. And it's in beta now. It's been out for a little bit, digital, and it's going to go to print here soon. I have a coupon code for you later. But notably absent from this talk is Ben Wilson, who's my co-conspirator with both of those projects. Ben is constantly on Slack and constantly answering questions. I can verify for you he's actually a functioning human being and not a robot. I don't know how he is our principal engineer and also spends as much time answering questions for people in Elixir and helps me maintain Absinthe and writes a book, but he does a fantastic job. So this is a short talk, and there's a lot of stuff to cover, both in terms of GraphQL and in terms of our implementation of GraphQL. I need to ask the question, how many people here have done anything with GraphQL before? How many of you have anything with GraphQL in production? Okay, a few of you. With Absinthe? Oh, good. Well, I'm sorry for whatever I've done to you. Okay. So the agenda basically is we're going to do some quick background on GraphQL for those of you that might not have a good grounding in it. Some things that I think it brings and some ways that maybe you can push it into your companies. I've noticed talking to people during the conference that there's quite a few attendees that would love to use Elixir more frequently, and maybe they work at a place that doesn't use it. Maybe it's a Ruby shop or a Python shop or a PHP shop we've seen as well. And I think that GraphQL is a really good way of starting to bring Elixir in for service aggregation, so I'll talk about that a bit. I'll also talk about, of course, Absinthe itself in terms of how you get set up, and some important words to know as you use Absinthe, that if you were to drop in the Slack channel and people would say, you know, something about middleware and phases and everything else, you'd have no idea what it was. Our documentation is okay, but could be better, like many open source projects. And so having some of that background might be helpful. Okay, so some basics about GraphQL. I already told you that GraphQL came out of Facebook. It's really simple. What it actually is, it's a graph query language. And it's also kind of a data query language. So a lot of people, whenever they think about GraphQL, they think of it as an API. It's an HTTP API, and it replaces REST. Or should it replace REST? Or no, it doesn't replace REST. People have lots of opinions about that. But it's not actually, the API part is, yes, you can use it as an API. You can use it over HTTP. But it's actually just a language. It's closer to SQL in many ways than it is to competitor to REST. I have used GraphQL to do a really, really horribly verbose version of LS, right, where every single graph node was a directory. You could use GraphQL purely inside of Elixir to query a database, and it has nothing to do with HTTP at all. In fact, Absinthe itself doesn't know about HTTP. Absinthe plug does, but Absinthe doesn't. So there's a nice separation between those two things. This is what a GraphQL query looks like. The query that you see on the top there before the first curly is what's called the operation. I'll talk about what operations are, but this is a query, so you're just asking for information. I'm asking for a post that has a certain ID, and then you can see the information that I'm asking for about that post. You'll notice something that looks eerily like a table join in a way in SQL, which is that I'm pulling stuff out of author here, right? So I'm pulling the name out of author. Now, what sets GraphQL aside from REST in many people's minds is the fact that you get exactly what you ask for. So the client it's kind of an inversion of control where the client gets to make the decision on what they get rather than the server. There's protections in place, of course, because you can't trust the client. But in the normative case, you have exactly what you ask for and nothing else. So it's also an HTTP API. Of course, if it was just something that was a replacement to SQL, it wouldn't be that interesting for most people. So when the rubber hits the road, you're going to use it over HTTP most of the time. And so you can kind of compare it to REST in that way. The way that requests to a GraphQL server, like to Absinthe plug, work are, generally speaking, you do an application JSON post or a GET. I'll give you a suggestion, just always use post. That's the easiest way to handle this. Because GET can only be used for queries and subscriptions, I believe, as well. And a post can be used for mutations, which is the other operation type. So it's just easier just to use post across the board. And anyways, that means that you've got a much more space to send the information that you'd like to send. So you've got a query portion and a variables portion. I'm not going to delve deep into what everything in the GraphQL is, but everything with a $sign is a variable. That top line kind of defines what the types of those variables are expected to be, right? And the bang that you see there after ID means that that variable is mandatory. So those are the main pieces on the variables. And then I'm applying those variables both for the user and for the posts underneath. And we'll talk through how this stuff is executed, but the main thing to know here is that the request is going to include the GraphQL document itself and the variables, if you're using any, that need to go along with it. And the result comes back as a JSON payload. With a data key, you could also have errors. In this case, everything worked perfectly, except my computer decided to sleep. Aha! Everything worked perfectly. What a perfect timing for that to happen. Okay. And you get back the JSON results that you asked for. Okay, so actually getting this thing out there. There's a few different ways that people have done this. This is the dream way. The dream way is that you just replace REST entirely. It depends on your company whether or not that makes any sense, and also whether or not you have buy-in from people in your company that might not agree in your new religion, which is GraphQL. We have done this effectively with the exception of a couple legacy services. It's so cool to call Rails legacy, even though I loved Rails for so long. And we have our GraphQL API talking to the database just as if it was a REST service. Another option that you have is you can just use it for aggregation. You could have a GraphQL API whose job it is to, under the covers, go and talk to microservices. GraphQL can talk to a database just like REST would locally, but just like REST, it could also reach out to third-party services underneath, microservices inside your infrastructure. It could calculate values on the fly and then return them. It's pretty flexible, so you can do service aggregation. You could have RPC systems, whatever else you want below here. What's nice about this is if you have existing REST APIs, then you can build some Elixir thing off on the side that's got GraphQL, aggregates those for a user interface or for testing. If you don't like it, you throw it away, right? Another version, and this is weird, but I've seen this a few times, and it's kind of cool, is people that are stuck in the position where they really want to use GraphQL, but they can't convince everybody at their company to do it. So what they do is the REST APIs are normal, and then inside, all the rest, the controller endpoint does is craft a GraphQL query and then call GraphQL behind the scenes. The goal there being that they can expose the GraphQL alongside, and then one day when they convince everyone else in the company and or partners and third-party people that they don't need REST anymore, they can throw away the REST endpoints. And so they are actually just using it as a data query language. And they might do that via HTTP, or they might just do that directly. Absinthe has a run function that you can call that you can just run a GraphQL query and get the result back without HTTP at all. You can mix and match these. And so this kind of gets to the main point around that, which is if you're having a hard time getting Elixir into your company and that's something that you're interested in, we have seen several companies, this has been their way of pushing Elixir, is to just build this GraphQL thing as a proof of concept and see if it works. Matter of fact, the last talk that I went to, which was Teachers Pay Teachers, did that, which is kind of cool. So GraphQL is not just about queries. You can do queries, which is where you request information, and that's great. But you can also do mutations. Basically, a query and a mutation are the same thing because I'm still getting data back. In this case, I want to create a post, but I want to get back the assigned editor, and I also want to get the publication status, right? But there's a side effect during the create post. This is not unlike in REST when people have decided to implement REST where you do a post and you get back data, which is not necessarily what you're supposed to do, but people do that anyways. That's built into GraphQL. The concept is I can send you something and ask for something back. You're going to make a change. So for instance, like if you had a status that would be dynamically defined during creation, but you wanted to return that back to the client, you could do that with mutations. Subscriptions are like the secret sauce. Subscriptions are the thing that always make people really interested in GraphQL, and they're kind of scary because they involve live data, right? They're cool because it means, hey, I want to know when something happens, and when that happens, you let me know, right? The GraphQL specification is actually kind of fuzzy on how that's done. It is generally done using WebSockets, but this is the really hard thing to implement, and this honestly is the part of the specification that many of the other implementations don't do very well. Luckily enough, we happen to be sitting on top of Erlang OTP and ERTS, and we've got things like clusters and all kinds of cool things like Phoenix Pub Sub and CRDTs, and all that stuff's available to us. And so we can do some really interesting scalable live data with subscriptions. For a long time, people were asking us why isn't there a new release of Absinthe? Why isn't there a new release of Absinthe? And that's because all we cared about for 6 months was making sure that we nailed subscriptions better than anyone else out there. which we think we have. So yeah, WebSockets are cool. One thing that I want to make a point about with WebSockets, I talked about with HTTP and with it as a query language. GraphQL is the same in all of these cases. So Absinthe can support you sending queries and mutations across WebSockets too, transparently, just as with HTTP. What's awesome about that is you are in GraphQL mode the entire time in your brain. Like when you think about the problem, you think about it in terms of GraphQL. Think about how this works in REST land, right? Where you've got a user interface and you are normally just pushing REST, you're doing REST calls all the time. Suddenly someone says, oh, I want to do live data and I don't want polling, I want real WebSockets. Well, how do you do that? You can't do HTTP over WebSocket, not really, right? There's so much of REST that's tied together with HTTP that it kind of breaks, it totally breaks your system. You have to come up with some new protocol. And so, for instance, Phoenix channels are great. They don't define a protocol for you. You're suddenly creating your own message passing payload protocol across channels. We actually handle that for you using GraphQL. You don't have to know about any of that at all, which is pretty cool. Okay, some quick things about GraphQL and how it works. Obviously, when a client asks for data, the server needs to know, A, how to get the data, and B, whether or not they're allowed to have it, right? And the way that GraphQL servers handle this is that you have to define a schema. This is the upfront work that you're doing. In many ways, creating a GraphQL API is all about creating your schema. The rest of it is just some configuration. This is the actual meat of your API. You start out by creating object types. So this is not unlike anything else where you're dealing with relational databases. You think about what your entities are in your system, right? So in this case, we have users, posts, and comments. Those are object types. And then they have something called fields. And you can think of fields as the associations or transitions that exist between those object types. If you talk to a graph nerd, right, they're going to call the object types nodes, right, or vertices even, and they'll call the fields edges quite frequently. If you read the relay documentation, it gets to be super unreadable because they start doing that in various places, and they lose some of the audience. But this is basically the way that it works. This is really, if you think about any system where you have normal ecto schemas, you already know this anyways. You're already defining your data as a graph, probably. You're just not thinking about it as a graph. But ultimately, that's what it is. So fields. If you take this a little bit further and you think, well, you know what? My user type, it's a type, but also a string is just a type, right? And we like types being from the functional side of things. If you just think of those as types, then essentially it's the same deal. So a post has an author, right, which is of type user. Well, a user has a name, which is of type string. So there are some built-ins, and you can create your own scalar values. The only difference between objects and scalar values is that scalar values don't have fields themselves, right? They don't have outward fields. Okay, and there we also have enums, there's unions and interfaces for abstract types, so that if you have types that work alike, you can discuss them. Think of things like search results where you might have different types of results returned, stuff like that. And hopefully someday there's also input types and all kinds of interesting things. Okay, so obviously if you define how everything is in the system, like what the layout is, essentially, you still need to define how you get from one piece to the other, right? Which is if I have a user, how do I get that user's posts? This is kind of built into Ecto, right? In Ecto, you just define your association, and it knows the SQL magic that needs to happen there. GraphQL is a step further up, and so when you define a resolver for a field, you have to tell it what to do. It might be use Ecto, right? It might be call a microservice. It might be calculate a value. It might be queue this thing up for batching because I'm going to do a bunch of data operations and then return the value that you need so that we can do this in a performant way. The main thing to know there is that you have these resolver functions that are responsible for actually finding the next step in the graph. Another thing that's very important is that in your GraphQL schema, if you remember, I'll show it to you on the next screen. But you need to define roots for the operation type, so a query root, which is just the entry point into your graph. Like, where can they start? Can they find all the posts? Can they find a specific user? What's the outermost point that they can enter into your graph? And so if we talk about this, for instance, we're going to walk through a GraphQL execution here. Posts is this query, this outer query is actually you can just think of that as an object. That's your entry point to queries. So post has to be a defined field on that query type, otherwise it doesn't even know it's there. And you'll get back an error saying, I'm sorry, I don't know how to do a post query. These arguments that you see right here, matching and limit, those are arguments that get passed to that resolver can then use to find the posts. So here, this is a query operation. We're going to resolve the root query value. We're going to find its post field. We're going to provide the matching and limit arguments to it. And then we know, because our schema has defined, that post is going to return a list of post objects, right? We're going to show the code for how this works in Absinthe, but it knows the next step. And then so for each type, that curly on the right-hand side there says, as we go deeper, now I'm inside of a post. And so for the post, I'm going to resolve its title field. It's going to give me a string. I'm going to hold on to that value. So all this is, the whole process of getting a GraphQL document and executing it, as far as the GraphQL server is concerned, is essentially to interpret your document. You can think of the GraphQL server as an interpreter. You've provided this document, and it's going to interpret it while referring to the schema. It's just going to walk down your graph. You give it a tree, it walks the graph, it gives you a tree back. Right? So you just go deeper and deeper, and it's just collecting data all the way through the process. Resolving the body field, it holds on to it, and it says, then it's walking back out. And when it's done, it just takes all the saved data and it returns it as a JSON blob. Two more things about GraphQL that are important is introspection. This is one of the coolest things about it. When you create a schema, you can document every single piece of your schema, right? You can document every single type. You can document every single field. You can get all of this information using a normal GraphQL query that you send to your server that just has some special semantics. They use double underscore field names, which are kind of built-in fields that you get for free. And you can introspect your schema. Because of that, people have built really cool tools that you can use, which, by the way, we ship with Absinthe plug, which are available. You just drop it in your Phoenix app. Then you can mount it and go to a URL and be able to use this directly. If you want to use it in production, you can. If you want to use it in development, you can. So with this, you have access to all the types. You have access to all the documentation. So any documentation that you've added for your types, you can see. Compare this to REST briefly, right? There is nothing for this besides handmade standards that have come around long after REST has, right? There's a few different competing ideas in and around this world, like Swagger and things like that, JSON API, but nothing cohesive. This is actually built into it from the ground up. And so you can do a lot of cool things with this. You can run a query, which is nice. You can save queries. You can set HTTP headers and all the rest, the normal things that you'd expect from like a REST client be able to do. You can set your variables. They also do some cool stuff with letting you copy like how to do this exact thing using curl, and you can copy it out and how to do it from JavaScript, so you can see how a client might call that GraphQL. Some really nice tools. We have used this within our company as an interface to, this is our administrative panel in many ways. Like you could have a GraphQL schema that is your admin panel, and you just give to your internal team. And that's it. You don't build a UI. It's also not as ugly as the one you're probably going to build anyways, because you don't have time to pull a designer in, or you just, you have to get it done. This is a great way of just giving an admin API to your internal team. And you can put it behind something that protects it from external access. That's cool. So that's great. I give you a lot of theory stuff. And basically actually only a very shallow amount of that. But how do we use it? So this is really not all that surprising. I think you've seen these kinds of things before, where you're just installing things. So I don't think we really need to dig in there. You could just drop in Absinthe plug and not even have Absinthe, because Absinthe is a dependency of Absinthe plug. But I like to be thorough. I like to have both of them in. You're probably not going to use Absinthe without Absinthe plug unless you're building something really interesting. And if you do, you should let me know. Like a client. So I would love it if someone built a client, so I don't have to. And then you're going to define a schema. Your schema is just a module, right? We're going to talk about how you actually build one of these. All you have to really do is use Absinthe schema, which gives you the tools that you need to build your schema. So if you are a web minimalist and you just want to use plug and plug this in, you can do that. You just have to know what your schema is. You can just drop in Absinthe plug. Application GraphQL requests, by the way, that's a particular MIME type where you're just sending a document. You're not sending any variables. It's not particularly common. Almost everybody is sending these requests via a JSON payload, but you can do that. The problem with that kind of thing is then you're interpolating values inside your GraphQL document instead of using variables. It becomes really messy. So it's much better to use application JSON. You can piggyback off of plug parsers. This will give you both application JSON and application GraphQL requests that you can use. It's very simple with the plug. Now, if you're more of a pragmatist and you're like, I want my batteries included, I want to use Phoenix. It's not hard. There's a couple ways you could do it. You could, if you only care about GraphQL and this is just for API and you don't have anything else, you could just put it in your endpoint and drop your router out, right? You could just remove your router. Just put it at the bottom there. Same deal as plug, really. Very, very similar. Just those two lines there. However, the normal case that we see with people is that they're using forward to Absinthe plug, and you can just use that with a normal forward line. There's some additional options here for subscriptions and stuff like that. We're not going to get into, but it's in the documentation. So, about subscriptions. For subscriptions, our subscriptions implementation does not require that you use Phoenix at all. It's just that for the pub sub stuff, we have an implementation of our subscriptions that uses that. You can totally, it's just a behavior, so you can create your own. We've seen people create all kinds of interesting things, including ones that don't use WebSockets but publish to Kafka. So you can do that, but if you want to just have all the batteries included and have cross-cluster subscriptions working for live data, use Absinthe Phoenix. And then what you need to do is in your application.ex, we're going to want to add Absinthe subscription, a definition of that as a child, OTP. And then there's some small things that you need to add to your endpoint so that your endpoint has access to some things. And in your user socket, which is under channels, you'll want to also use Absinthe Phoenix socket and set your schema there. People always ask about subscriptions and authentication. This is just a pointer that they need to look at Connect to. There's a guide for that. We have quite a bit of material under hex docs. We're very similar to Phoenix in that we publish guides into our hex docs, and there's quite a bit of material there for you to look at. We are also very lucky in that we have 2 members of the Absinthe team that manage all the JavaScript. Christian and Mauro are my 2 favorite people in the entire universe because they do all the JavaScript for us, and they do a great job. If you were working with a front-end team that wanted to do vanilla JavaScript, fine. We've got a package in NPM for you. We have an organization there. We also have drop-in support for Relay and Apollo, and both of those do include support for subscriptions. You can also do file uploads over JavaScript, all kinds of fun stuff. Schemas. So we talked about this before, where you have a user and you have posts, and you have an author and posts, right? Basically looks like this. Pretty simple. These macros were hell to build, so please use them. Basically what happens in a GraphQL, in our schema, in our approach to schemas, is that these macros occur in all of the checks on validity of the schema, which there's a bunch of stuff that comes from the specification, and a lot of optimization steps are handled during the compilation phase. So this stuff is pre-optimized for you in your module, not something that's dynamically done. People have done dynamic versions on top of Absinthe, but straight out of the box, we go for as high performance as possible. So these are just, here's your object for your post and for your user. Main thing here is that you define your fields and what the types of those fields are. There are two additional macros that you can use. There's a list of, and there's also one called non-null, where you can set a constraint and saying this is always going to give me a value back, which we will check. There's quite a few additional macros in here where you can set arguments that you expect for a particular field, which you can say are non-null. If you don't get those, then they will get an error back, and your resolvers will never fire. So there's some safety measures in place. So those are the two fields that we talked about before that go between the post and the user. This is what a resolver looks like. It's not particularly complicated in that what it's doing. So we can set the resolver by using this resolve option. You can also do it inside of a do. So you could do field post, list of posts, do, and inside that block, call resolve. There's a separate macro for it. But in this case, we're just going to use this capture on this function. And we're going to call find posts. Now, the resolvers get 3 arguments. They get the parent, so that's the object that they're on. In this case, it's whatever user I happen to be in. Any arguments for the field, which there are no arguments that are given in this case. And there's a struct that has a ton of information about the internals of Absinthe that you can get to in info. It's also called resolution sometimes. And all this is essentially doing is just doing an ecto a soak on the user to get the user's posts and returning it. Right? This isn't the most performant way of handling it. If you can expect that maybe they list a whole bunch of users and get all those users' posts, but that's things called batching to protect us from things like N+1. But this is basically the contract with a resolver is it's going to return OK and the data, which is basically the next step in that graph walk, or it's going to return error, and there's quite a few different types of error structures that you can return. And that stuff comes right back out to via JSON to the user. So that's those two. Now, one really important thing to know about Absinthe is that unlike the standard GraphQL implementations, which basically have 3 phases, they think of parsing, parse time stuff. Then they think of validation, which is when you're checking arguments for fields. And then they think of execution. Everything in the specification deals with those 3 things. You obviously have to parse something. Validation, if you don't pass that, then nothing gets executed. So you're not doing queries or anything. And then, of course, execution is what does the work. In Absinthe, we've broken those up into at least 40 phases. And that sounds weird, but what we do is we have a pipeline that has modules that you can list in it, and the only job of that module is to take the tree, which is essentially a modified version of your AST, of the AST for the query. It's called a blueprint. It's our intermediate form, actually. And all it does is modify it. So it just takes something in and then drops that modified tree out. So it might flag part of that tree as an error, like, oh, this is invalid. They didn't do this right. The document's not correct. Or it could add data to that tree. And that's the resolver is actually being executed inside one of those phases. And at the very end, there's a phase that just harvests the data out of the tree, and that's what gets returned. What's cool about this is those phases, that pipeline actually really has nothing to do with GraphQL at all in and of itself. Like, you could use this to do anything, really. It's just input goes in, and there's output at the bottom. So if you don't want a validation, let's say you have a non-standard client sending you weird stuff, but you need to deal with it, you can just remove a phase. Or if you have some other additional constraint you want to add, you want to go beyond the specification, add a phase. If you want a phase that adds additional phases dynamically while the pipeline's being executed, you can do that. So you can do a lot of, we've seen people do all kinds of crazy things, and we set it up this way so that every time someone had a feature that they just needed, that it didn't need to be necessarily part of Absinthe. It could be something that is a house style. It's another difference between us and the other implementations. So just some frequently asked questions about Absinthe. How do you handle authorization? Basically, Absinthe can take as input something called context, which comes out of the plug private, similar to what Phoenix does for controller actions. So basically, to let Absinthe know about, for instance, an authenticated user, you can just build a plug and just put that before Absinthe plug, right? And then Absinthe plug has something called put options, where you can put additional data in that then Absinthe will have access to. And once you do that, this is how you add your plug before Absinthe plug, right? Simple, in both for plug and for and in Phoenix. And once you do that, you have this context as part of that third argument in your resolvers, right? So in this me posts, right? Yeah, so for the me, this is what I'm talking about over there. And this is the query do, by the way, is your root object. Every schema has to have one. But in this resolver, it gets that context. And so because back here in our context plug, we found the current user down there and build context, and it's available, you can then make decisions on a field-by-field basis of what to do. So if I want to know, this is the currently logged in user. Me is always going to be the currently logged in user, or it's going to be returned as nil, right? And that user is not logged in. And then none of the fields underneath it would be executed. So this is a way that you can always get the currently logged in user's posts. You can do ad hoc checks too. So for instance, if you want to do authorization checks that your current user is an admin, you can just do a pattern match in your resolver function. It's very straightforward. We have something called middleware in Absinthe, and what middleware is, obviously be really painful to go through all of your fields that are authorized and have to sprinkle in these matches everywhere. That you need to do this particular check. So what middleware is middleware is a way, it's kind of similar to plug. Middleware is run during resolution, and you can add it on to any field that you want. So in this case, here's a piece of middleware that does the check for admin required. And you can see me applying that here. There's two ways to apply it. One's the middleware macro that you just set it up before resolution. Because this resolve here, what it actually does is actually just called middleware. It's just applying another piece of middleware that adds a default resolver. But this middleware will require an admin before this resolution ever happens. If it doesn't happen, then based on the middleware here, it'll say unauthorized, right? So you don't have to do that all over the place. You just do it in one place, apply it where necessary. There's also a hook on your schema, and I'll call this middleware 3 function for every single field, applying middleware as you want. So you can just put that in one place. Like if you know that everything that ends with admin is always going to have to have the admin middleware applied, then you can just do one match and have that applied everywhere. This was the most desired feature of Absinthe early on, which I totally understand because schemas were a mess until we had it. We have concurrency in our fields. So you can do this in queries as much as you want. The specification says that everything has to be serialized. for mutations. But for queries, you can use this async plugin. This just uses task async with a 30-second timeout by default. And basically, at the very end, it just waits for everything and then returns it. We have n+1 query problem. If you've got n+1 query problems, which everybody does if they've got a appreciably complex schema, you can use the batching plugin. So in your resolver for that, this lets you say, I want a batch resolution of all of the users by ID. This is the function that you're going to call. And then when you're done, this only happens once at the very end. When I get the results back, this is how I get that author out. So basically it says, I'm just queuing this author ID up to be included in the query that you do later. When that query is done, give me back the data, and I'll take out the record that I need for this particular author. Right? So it only executes once. You get the data, and you move on. However, it's hell to read. Right? It's not great because it's complicated. This is why we have something called data loader. Data loader comes out of the JavaScript world. We've re-implemented it for Elixir. So with data loader, you can define something called sources. So in this case, this is usually around a context. And that's what it becomes, which is much better. This is actually kind of similar to if you're doing queries in Ecto and doing like a Ecto Assoc, but it's a little bit more flexible. Data loader, by the way, could be its own like 2-day course, so I'm not going to go any further into there. But it is completely separate. It has nothing to do with Absinthe. Technically, you could use it in other projects to do batching, which is nice. Obviously, a schema module is one big module, right? Well, that would not be great to have to maintain. So we have ways of splitting it up. You can extract your types into other modules and just use Absinthe schema notation. You can import those, and you can import individual fields from objects into different parts of your schema. Last bit here. I told you this was a run. So version 1.5, which is coming out, all the schema definition stuff that you saw was great, but it could be more flexible. We could have a pipeline that would make it easier for people to contribute. No one contributes to those macros because they're insane. I wrote them, I know it. So we're completely re-implementing that piece in a backwards compatible way. It's going to be a lot easier for people. For those of you that know about GraphQL, we will have SDL support and schema stitching, which are two new features. SDL support just landed in the specification this month. We're also I'm currently re-implementing our parser right now. It's leaks and yek at the moment. It's going to be moved over into using Nimble Parsec, which is something new that Jose wrote, and which is really cool and fun. And my background's in linguistics, so I just want to write parsers whenever I have the option. We'll also have more flexible imports, so you can import only certain things or import except certain things into your schema from other places. We'll also have an Elixir GraphQL client, which is a necessity when you do schema stitching, which is basically when you have schemas for microservices that you're trying to pull into one place and transparently allow people to access. So we have to have an Elixir GraphQL client, so that'll be part of Absinthe. And then there'll be some data loader improvements. Absinthe from the very beginning we've kind of branded it as a GraphQL toolkit, and so there's pieces that people can use for various reasons. So people could write even better GraphQL clients that just use our Absinthe GraphQL parsing and client code under the covers if they wanted to. Okay. Thank you. That's if you want to follow me on Twitter, that's where you find me. AbsintheGraphQL.org. Notice no S because it's on GitHub, so not HTTPS. AbsintheGraphQL.org has the links to hex docs, everything across the board. We have a Slack channel which has, 1,000 crazy people in it that ask questions. And we're in there all the time answering questions and helping out. It's a great group of people. And that's the book. The book is going to be going to print soon. That code will work, unfortunately only for the digital copy because we're not selling the print copy yet. But if you'd like to purchase it, that's 300 pages about this. So significantly easier to follow, I hope. But hopefully this has been helpful, at least to give you a taste of what the landscape looks like. Okay?